Okay, good morning, class. Looks like I might just be here tomorrow. We'll be there tomorrow, hopefully. Hopefully, I'm crossing my fingers. So, thank you for being so patient. So, let's continue on with permutations and combinations. I think this should be a lot more clear today. Hoping you didn't have too much trouble yesterday, but usually the second day of this, it just kind of clicks. I'd like you to do your homework in class today. I'm going to do a short lesson with only 4 problems, and then I'll have you stop the video, do your homework for about 15 minutes, and then we'll come back and we'll go over the answers together. After you're finished doing the homework and we go over the answers, I'd like you to put Monday, Tuesday, and Wednesday's homework in this order, highlighting which one's which and with the proper heading. For instance, textbook, page, I don't know what it was right now, page whatever, 3 through 13. I need to see all of that when I go through and look at these, and just go ahead and put them in the inbox for me. I'll pick them up tomorrow morning. Okay, so let's get started. You don't have this worksheet, I just want you to pay attention, and then we'll get you guys going. So determine whether each situation involves a permutation or a combination, then find the number of possibilities. Okay, so yesterday we talked about permutations and combinations. So permutations are anything that has order. A lineup, a bracelet, anytime you're putting something in a particular order. Combinations is just like grouping something or just determining things based on a group. So if you're thinking groups, then that's combination. I was looking at something funny online. It talked about a combination lock. A combination lock should actually be called a permutation lock because a combination goes in order. So I thought that was kind of funny. Anyways, selecting 2 employees to work on a presentation out of the 10 employees that work in the office. So this would be a permutation. This would be a combination. Selecting 2 employees to work on a presentation out of 10. That's a group of 10 employees, and we're going to pick 2 of them. So I've got 10, combination, 2. That can be translated to 10 factorial over 10 minus 2 factorial, 2 factorial. Should be a little bit longer there. Which equals 10 factorial over 8 factorial, 2 factorial, which equals 10 times 9 times 8 factorial. I'm going to use commutative property and switch these around. And 2 is factorial is just 2 times 1. Cancel 1. And I'm left with 5. So 5 times 9 is 45. So 45 different ways that we can select 2 employees out of 10 employees. Okay, arranging the letters in the word cell phone. We are arranging. This is a permutation. Also, we have multiple letters in here. So this is a repeating permutation. Okay, so we have a double L. So we have 2 L's and 1, 2 E's. So we have to account for both of those. So let's see how many letters are in cell phone. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 factorial, and then I have to put in the denominator 2 factorial, 2 factorial, because I have to account for 2 L's and 2 E's. So 2 factorial, 2 factorial equals 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial all over 2 factorial, 2 times 1. The 2 and the 1 cancel with the 4, and I'm left with a 2. My 2 factorials cancel. And if I put that in a calculator, I'm going to get 90,720. Write that down if you'd like. Pause. But I'm going to go in. All right, 25 students enter the science fair. How many ways can first place, second place, third place, and honorable mention be awarded? Okay, so this is putting it in order. This is a permutation, so it's going to be 25 permutation, and I'm choosing 4 different 1, 2, 3, 4 places, which equals 25 factorial over 25 minus 4 factorial, which is 25 factorial over 21 factorial, which is 25 times 24 times 23 times 22 times 21 factorial, all over 21 factorial. These cancel, and if I put that in a calculator, I get 303,600. Hopefully this is making more sense today. Last one. There are 12 boys and 20 girls in this knowledge class. How many ways can 2 boys and 3 girls be selected from the class? I told you that, so there's not 12 boys and 20 girls. I don't know, there might be, but I don't know. Anyways, so I have 2 different things I'm choosing from. I've got 12 boys, and I'm going to choose 2 of them, and we'll learn and means multiply, and I've got 20 girls, and I'm going to choose 3 of them. Alright, I'm going to show you a trick in your calculator. You're kind of going to be upset with me for having to do all the work before, but you don't have to do all the work for your homework today. Alright, so I downloaded a program on my computer, and I kind of want to keep these numbers up here. So let's do this. Alright, I'm going to put 12 choose 2 or 12 combination 2 into a calculator. So here's 12. I'm going to hit the probability button right here, and your calculator could say a couple different things. It could have numbers next to it, or you may have to go over on the arrow. This one doesn't work that way, but this one happens to be where I have to plug in numbers. So if I want NCR, then I need to push 2, and that tells me 12 combination. Now I just need to put my 2 in there. 2, and then I'm going to hit enter. And I get 66. Multiplied by, and I'm going to do this one. 20 choose 3. 20, I guess I should clear it just in case, right? 20, probability, I want the C, this one's for permutation, this one's for combination, so I'm going to put 2. Now I've got 20, combination, and I need 3. Enter. And 1,140. And if I multiply those both out, I get 75,240. Alrighty. So now that we've done all the hard work, I want you to go ahead and practice this in your homework today. So let's recap real quick. Our permutation formula would be n factorial over n minus r factorial, n being the number that we have to choose from, and then r being the choices that we're making. combination formula would be very similar. N factorial over n minus r factorial r factorial. When do we use this one? We use this one when we are talking about order matters. Sometimes we use keywords like arranging or in a line. It's usually arranging people or things. Okay, when we use this one, order does not matter. Order doesn't matter. Choosing from a group. All right, so I want you to go ahead and pass out the Permutations and Combinations worksheet and get started on your homework. Go ahead and pause me for about 15 minutes. Okay, so number 1, you should have got 20, permutation, 3. 20 athletes enter in a 10K race, first, second, and third. Well, that's order. So order matters. That's permutation. Put that in a calculator, and you should have got 6,840. Selecting 4 students from the senior class of 700. Well, that's a group of students, and we're choosing 4. So that's 700. Combination 4. And you should have got 9,918,641,075. All right, selecting 1 book off the list of 15 to read for a book report. Okay, so that's selecting. So we're not arranging, we're just grabbing one. So that would be 15 books, combination 1. That would be 15 different ways. Placing a math book, a science book, English book, and history book on a bookshelf. Okay, placing them in order means order matters. There has to be some type of order if they're going to be on a bookshelf. So that would be 4, and we're going to place all of them on the shelf. So that would be 4 permutation 4. Which equals 24 different ways to do that. How many ways can 8 students stand in line for prom pictures? Okay, they're standing in line. Line means order matters. So I have 8. Permutation 8 equals 40,320. There are 12 desserts at Hometown Buffet. You told yourself that you will only eat 2 of them. How many ways can you pick 2 desserts to eat? I'm choosing out of a group of 12 desserts. So order does not matter. 12, combination 2. And the answer to that is 66. There are 20 boys and 15 girls in Mrs. Bengal's Algebra 2 class. How many ways can you select 3 boys and 2 girls to be in a math completion? That should probably say competition. Okay, so if I'm grabbing boys out of a group and I'm grabbing girls out of a group, then order doesn't matter. This is going to be a combination. So I've got 20 boys, and I'm going to choose, where does it say it? 3 boys. Multiplied by, I've got a total of 15 girls, and I'm going to choose 2 of them. So let's see, 20 choose 3, or combination 3 is 1,140, and 15 choose, or combination 2 is 105, for a total of 119,700. How many ways can 3 cards be selected from a deck of cards when 1 card is from one suit and 2 cards are from another suit. So from yesterday, we learned there's 52 cards in a deck, and 52 cards in a deck means that there are 13 in each suit. So I'm going to have 13. I'm just picking a card or choosing a card. So that would be 13 combination. We said 1 card from one suit, and 13, and I'm going to choose 2 cards from another suit, which equals 13 times 78, which is 1,014 different ways to do that. Alright, a special kind of permutation, arranging items that have repetition. Okay, so this one's a little bit different. Arranging the letter in the word cat. 1, 2, 3 letters with 0 repetition. That's just 0 factorial is always 1. Factorial is always 1. So this is just 3 factorial over 1, which is 3 times 2 times 1, but I'm going to go ahead and go in my calculator really quick and show you what 3 probability factorial would be. 3. You can use that button as well. Enter. And I get 6. Sometimes when we're trying to practice something, it's easier to practice it with something that I can do in my head pretty quickly. So I know 3 factorial is 6. I practiced it on my calculator, and in fact it is 6. Arranging the letters in the word happy. Okay, 1, 2, 3, 4, 5 letters in the word happy over 1, 2. I've got 2 P's that I have to account for here. Okay, practice that one in my calculator. 5 factorial, 2 factorial. Alrighty, so I'm going to do 5 factorial. I'm going to divide that by 3. Sorry, 2 factorial, right? Yep. Put this over here so you can see it. 2 probability factorial. Enter. I got it. See? Arranging the letters in the word banana. 1, 2, 3, 4, 5, 6. 6 factorial. See how many repeating. 1, 2, I've got 3 A's, and I've got 2 N's. This one you got to be careful about. If you're going to put this in a calculator, you need to put parentheses around it. If you don't put parentheses, you're basically going to tell your calculator 6 factorial over 3 factorial, and then multiply that by 2 factorial. And that's not correct. Oops. Here's my eraser. Alright, so if I put this in the calculator, it's going to be, let me clear my screen here, 6 factorial divided by parentheses 3 factorial and 2 factorial in parentheses. Enter. 60. Alright, arranging letters in the word Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. Let's see the repeaters here. I've got 1, 2, 3, 4 I's. I've got 1, 2, 3, 4 S's. And 2 P's. Put that in my calculator. 11 factorial divided by parentheses 4 factorial, another 4 factorial, and a 2 factorial. That's right. 11 factorial divided by 4 factorial, 4 factorial, 2 factorial. So I just need to do in parentheses and enter. And I should have got 34,000. Oops. I have written down. 34,650. Okay, that concludes this lesson.